In this video, we'll be doing the question you see on the screen from the 2023 Leaving Cert Higher Level Maths Paper 1. If you're looking for a different question from this paper, there should be a playlist in the description below. And if you're looking for a different paper entirely, have a look on my channel. I'll be doing all of this on a whiteboard, hopefully just like you're used to your teacher doing. But remember, we are on YouTube, so take advantage of that. Pause, try the question first, and even change the speed of the video to half speed or 2x speed if that's your thing. If you find this video or any of my videos useful, I would greatly appreciate a like, a subscribe, or especially sharing it with someone else you think might help. It might help. In question 6, we're given these two functions here, fx and gx, and we're simply asked, for part 1 at least, we're simply asked to find the two values of x for which these are equal to each other, for which fx and gx are equal. It's not too complicated, they just want us to put the right sides equal to each other. So let's do that. X plus 4 is equal to x squared minus 2. What x makes this make sense? Rearrange this, we should get ourselves a quadratic. X squared minus this x minus the 4, we'll get minus 6 equals 0. Let's see if we can factorize that. If we can't, we'll have to use the minus b formula. But we can. 6, the factors of 6, 2 and 3 should work quite nicely to get to a 1 here. We need a minus 1, so minus 3, a plus 2. X is equal to minus 2 and x is equal to 3. Solves that quite neatly. Now, if you found part 1 a little bit easy, that was really just a warm-up for the part 2. In part 2, we're given this diagram of the same functions, fx and gx, and there's a shaded region. They want us to find the area of that. And when we're looking for the area of any curve, or any non-simple straight line curve, or the area in and around it, underneath it, between them, we should be thinking integration, and that's exactly what we're going to use here. I'm going to answer this question in the simplest way, but I understand some students do it slightly different. So when I'm finished, I'm going to point out the other ways you could have done it and why it's maybe a little dangerous and why my method might be a bit better. Okay, now my method is not strange or anything. It's not something you should find unusual. I'm simply going to find the area between two curves, not the area under one curve, the area between two curves, because that's what we have here. It's line, it's a very simple curve, and this quadratic curve, and the area between them. So to find the area between two curves, it's simply the integral of the upper curve, the upper bound of your thing, and that upper bound is this fx here. That's x plus 4. And then minus, so it's the upper one minus the lower one. So the lower one is, in this picture, is this gx here. So it's minus gx. And if we integrate all of that, respect to x, between the limits we want, in this case we want between minus 1 and 2, minus 1 and 2, this is simply going to find the answer we want. That's it. This is all we have to do. Yeah, I'll wait till the end to talk about doing it separately in different parts. Okay, to clean this up a bit, we can just multiply this minus in. We'll get minus x squared. So clean all this up. We'll write it in order. Minus x squared. The next would be x's. There'll just be a plus x. Plus x. And then finally we'd have the numbers. We'd have a 4 minus minus, so we get a plus 6. And all this with respect to x between minus 1 and 2. Integrate this. It's quite simple to integrate polynomials. X squared becomes x cubed. So yeah, I'll write it here. We'll say I. Say I equals this. I equals x cubed. This 2 becomes a 3. And then we divide what's in front. So there's a minus 1 there. So a minus is a minus 1. So we get minus 1 over 3. The next one, the x becomes x squared, and we divide what's in front. There's a plus 1 there by the 2. And the 6, you can think of this as 6 times x to the power 0. That becomes x to the power 1. So it's x power 1, and the 1 divides what's in front, which is the 6. So we get plus 6 over 1. And that's the integral. We just have to evaluate this between -1 and 2. That means put 2 in, and we'll do that now. We get -1 over 3 times 8, plus we'd get 4 over 2, that's just 2, and we get 6 times 2, that's just 12. And then we take away this number being put in. So we get minus, and we put in -1. So we get minus, 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 times this minus, that's 4 minuses, including this minus, 5 minuses, we have a minus overall. So this is 1, 1, 1 over 3, so it's 1 over 3. Again, this is a minus, and then we put -1 in twice. So minus, minus, make it plus. This minus makes a minus overall. If you're unsure, use a calculator, do this slowly, but we end up with 1 over 2. Last case, we take away this and we put a minus in. So we get 1 minus goes in, and this minus turns into a plus. 6 times 1 is 6. And we clean all of this up. Let me see, I'm sure I have the answer done out here. We get 16.5, and that's the full answer. That's the area between these two curves. Now let me just point out some of the errors some students could have made. A lot of students like to break this up, and they could have got the area under this curve on its own, and that would have been okay, except you would have got a little extra area here. You don't want this area down here, but you would have got it. Anyway, that's fine. That would have given you an answer there. And then they would have tried to get the area under this curve. So between here and, between here and up here. Apologies. So that would have given this weird thing. So the problem is it doesn't give you this area. It gives you minus this area. And it gives you plus this area. And it adds it together. So if you wanted to do this, you would have had to split this into 2 parts. You would have had to get the area of this and change the sign. And then you would have had to get the area of this and change the sign. And ultimately, I guess you would have got this area minus this number, minus the minus number you would have got here, or add this absolute value. And then this is doing all that for you. It's this, take away this total number here. But if you wanted to separate, you would have to be really careful. You'd have to split this guy into 2 parts, and so you would have ended up doing 3 separate integrals instead of 1 combined one. Hopefully that makes sense. Area between 2 curves is always quite simple. The maths fixes itself when you do the area between 2 curves. If you break it up individually, you're going to have to be really careful. In part B, they give us this question to solve, an integral where there's 2 unknowns. There's x and b, and we're asked to find b. The thing is, we're integrating over x, so x actually gets disappeared in doing the integral. So there's only one unknown here, and we're asked to solve it. So yeah, let's begin. We try to integrate this. First thing to notice is b is a constant. They tell us it'll become more important later. It's a positive constant, but it's a constant. So that means I can write this integral again with b outside it. And all that's inside is e to the power of bx dx. We know this equals e. The thing is, I know how to integrate. The special things about e, the reason we use this special number of e is it integrates and differentiates really easily. This is in your formula table. But the integral of e to the power of anything is just, it comes out as the same. So we leave b here, and this comes out as e to the bx. But the only exception is we have to differentiate what's up here. And if we differentiate what's up here, we get b. And in an integral, we end up dividing by that derivative. Again, this formula is all in your book. So we end up dividing by 1 over b. In this case, we just get a cancellation out here. And the answer is still equal. This is evaluated at b to 0, and the answer is still equal to e. When I said earlier the x disappears over the integral, it disappears in the sense that we have 2 values to turn it into. These 2 values go into it, and 0 is a known value, and b is the same as the b we were looking for. So I should have said that earlier. Anyway, So let's put b into it and put 0 into it. So once we put b in, we'll get e to the power of b times b, which is b squared. And then minus, we put 0 in. B times 0 is 0. E to the power of 0 is 1. E minus 1. And all this equals is e. Okay, now we have an equation with one unknown. Remember, we know e. It's on our calculator. It's 2.7 something. It's a known number. And the only thing we don't know is b. So we try and solve for this. Rearrange it a bit. We get e to the b squared is equal e minus 1. How do we get rid of e? Like, how do we get b on its own? So the thing that destroys e is the natural log. So we just take the natural log of both sides. This side, natural log of e destroys it, and we're left with this. On this side, the natural log, be careful. A lot of students want to do something silly here, like the natural log destroys this e, and then take away natural log of 1, and they get in trouble then with natural log of 1. No, the natural log, you use the natural log on all of the left. You have to use it on all of the right. So there's no easy way to change this. But this is a known number. This can all go in a calculator. This is just a number we now know. So we can stay solving. B is equal to the square root plus or minus the square root of natural log e to the minus 1. Except not plus or minus. They told us b is positive. So be careful. If you left in a minus number here, you're going to lose a mark. They explicitly told you b was positive, so we should only have a positive. And that's our answer. They never told us how to write it. I think they'll accept this as full marks. This is the exact form of the answer. But you can go ahead and put it in a calculator, and you would get 1.14597, so on, so on. Usually best to round off to, I don't think they told you. Usually it's best to round off to 3 significant figures. So that would be 1.15, I guess. Anyway, all 3 of these I think should be perfectly okay answers. And that wraps up question 6. If you have any questions about anything I did there, see any mistakes I made, anything like that, let me know. I'll do my best to get back to you. Thanks for watching and have a great day.